Hello everyone and welcome back to my YouTube channel. In this problem we want to solve for x given that 4 raised to power x is equal to 30. This is an exponential equation and we're going to apply some basic laws of indices as well as logarithm to solve for x in this problem. We're given 4 raised to power x is equal to 30. First of all, let's look at 30 and see how we can break it down. I can break it into 2 times 15, which is exactly what I'm going to do in this problem. So it means I now have 4 raised to power x is equal to 2 times 15. And then I can divide through by 2 to get rid of this 2 here. So I'm left with 4 raised to power x divided by 2 is 15. Now, what next is required in this step? Let us look at 4 as it is here, 4 raised to power x. We can break 4 itself into 2 times 2 or 2 raised to power 2, which means that 4 raised to power x now becomes 2 raised to power 2 and then raised to power x. So divided by 2 is equal to 15. By the law of indices, which says if you have a raised to power m, then raised to power n, you can break it or open up the bracket to have a raised to power mn. Then it implies that this bracket here can be opened to give us 2 raised to power 2x, then divided by 2 is equal to 15. We are going to apply one more law of indices, which says if you have a raised to power m divided by a raised to power n, you can make this as a raised to power m minus n, because what we have here is division. So because we also have division here, we are going to apply this principle to the left hand side of our equation, which will then give us 2 raised to power 2x. This is 2 raised to power 1, so we have 2 raised to power 2x minus 1 is equal to 15. And then we apply logarithm, which is logarithm of both sides. Let's take the logarithm of both sides to whatever base we want. So we have log 2 raised to power 2x minus 1, I'll put this in brackets, is equal to log 15. This is in base 10. So the law of logarithm that we are going to apply here says that if you have log a raised to power m, for instance, this power here can be transferred to the back to give us m log a, meaning that the power we have here, which is 2x minus 1, can be transferred to the back, and then we have 2x minus 1, then log 2 is equal to log 15. Remember, they are both in base 10, and then we can now divide through by log 2. Divide through by log 2, so that this gets rid of this here, and what we are left on the left hand side with is 2x minus 1. Then on the right we have log 15 divided by log 2. So to solve for x in what seems like a linear equation here, because the highest power of x here is 1, we will then add 1 to both sides so that this becomes 0, and then the equation becomes 2x is equal to log 15 divided by log 2, then plus 1. So to solve for x, we will then need to divide both sides by 2. So I'll put this in brackets and say times 1 over 2. And this takes care of this. So we are left with x is equal to 1 over 2. If I open up the bracket, log 15 divided by log 2, then plus 1 times 1 over 2 is 1 over 2. This is our final answer for this problem. Thank you so much for watching. Hit that like button and subscribe to my channel, and I'll see you in my next video.